Assalamualaikum and good evening. My name is Muhammad Nazim bin Muhammad Kamarul Zaman Shah. We are from Group 8 from University Malaysia Perlis. Today we will present our project for AMJ40103, which is Industrialized Building System. Our projects focus on two-story residential house and its IBS score assessment based on CIDB and JKR guidelines. Okay, for introduction, uh, we know Malaysia construction industry is continuously evolving to improve productivity, quality, and sustainability. One of the key initiatives introduced by the Malaysian government is the Industrialized Building System or known as IBS. IBS focus on the use of prefabricate and standardized components which are manufactured in a controlled environment and assembled on site. Compared to conventional construction method, IBS can reduce construction time, minimize labor dependency, improve quality, and improve quality control and reduce material waste. Therefore, IBS adoption is strongly encouraged by CIDB and JKR, especially for public infrastructure and housing project. Okay, next, I will explain our project focus and objectives, which is our project focus on the selection of suitable IBS component and the assessment of IBS score in accordance with CIDB and JKR guideline. The IBS component selected for this project include prefabricate beams, slab, roof truss, and prefabricate walls panels. The selection of this IBS component is based on several criteria, including structure, performance, cost effectiveness, ease of installation, and sustainability and compliance with the JKR and IBS catalog. The IBS score evaluation cover three categories, which is structure system, wall system, and other simplified construction solution. The main objective of this project is to demonstrate how effective IBS implementation can enhance construction efficiency, quality, and sustainability while complying with national standard.
My name is Nurul Izzati binti Muhammad Zainuddin. For selection of IBS panels, it's a critical step as it directly affects the construction efficiency, quality of work, and also compliance with JKR standard. IBS panels are selected to optimize the construction speed, to improve the labor efficiency, and also to ensure the material consistency. Proper panel selection can help to achieve a high IBS score, and also the main objective is to balance the structural integrity, the architectural requirement, and ease of installation. IBS also supports sustainable construction by reducing material wastage, minimizing on-site error, and also allowing the use of formwork system. For modular coordination in IBS, it is a key principle in industrial building system. The building components are designed using standardized module dimension to ensure the consistency and repetition. In Malaysia, modular coordination is guided by MS1064, which provide a systematic framework for dimensional coordination of structure component and also architectural component. Modular grid lines were used in both X and Y direction to ensure the uniform spacing and alignment and also improve the integration of prefabricated components. Integration of the precast catalog is an important aspect to selection and implementation of IBS components. The catalog is provided by CIDB and the JKR IBS catalog, which is served as a reference for approved precast and prefabricated components. Use of all catalog listed components ensure the compliance with CIDB and JKR requirements, adequate the structural performance and durability, and also consistent quality and constructability. Next is the IBS versus conventional construction. For the installation speed, for the conventional method, it's slow and on-cast casting. For IBS, it's a fast and also prefabricated. For quality control, for conventional method, it's a site dependent. Meanwhile, for IBS, it's a factory control. For labor requirement, the conventional method require a high labor requirement than IBS panels. In waste generation, conventional method require a high while IBS is minimal. For JKR compliance, it may vary for conventional method while guaranteed for IBS panels method. And last, sustainability, the conventional method is low while IBS panel is high. For the IBS score, it is assessment to evaluate the level of industrial building system implementation in the project. The assessment is conducted accordance to the JKR and CIDB IBS scoring guidelines. The IBS score considered type of construction system used, the level of prefabrication, and also IBS coefficient assigned to each building component. This section covers the IBS component classification, coefficient allocation, and also IBS score calculation for the project. In IBS, there is the main categories, which is structural system, wall system, and others. For structural system, there is three, which is fully prefabricated component, which is for beam, slab, and also roof trusses. It is factory produced, high quality, and also fast installation. Second is semi-IBS component, which is in situ elements with reusable formwork. It reduces material waste and improves efficiency. Next is conventional component, which is it is a fully cast on site and there is no contribution to IBS score. So the calculation for IBS score is as mentioned, and the maximum point for IBS score for structural component is 50. For wall system, there is also three, which is first is fully prefabricated wall panels, which is it's off-site manufactured, it's fast installation and consistent quality, and also full IBS contribution. Second is semi-IBS wall system, which is modular or reusable formwork, and also partial IBS contribution. Lastly, for conventional walls, there is traditional block work and masonry. There is no IBS contribution for conventional walls. For wall system, the maximum point will be 20 points. For others and simplified construction solution, this category is contribute up to 30 points to overall the IBS score. It's included the prefabricated and standardized components beyond the main structure and wall.
I am Norafika binti Farviskan. I will be explaining about the IBS score calculation for this project. The construction area for this project is for construction of ground floor, it is 60.12 meters square. For the construction of the first floor area is 64.80 meters square, and the construction area for roof is 64.80 meters square. And the total area of this building is 189.72 meters square. And for the structural system, the beam that we use is prefabricated beams. For the columns is in situ columns using a reusable formwork system. For the slab, we use prefabricated slab on the first floor. And for the roof trusses, we use prefabricated roof truss. For the wall panel, we have used prefabricated wall panels for internal walls, and for the external walls we use block work system. For the other simplified construction solution, for beams we use 100% comply with MS 1064 part 10. For the columns used, 100% complies with MS 1064 part 10, and for the wall and slab we have used 71% and 800% complies with MS 1064 part 10, and for the doors we use 100% comply with MS 1064 part 10, and for the window also we have used 100% comply with MS 1064 part 10. Calculation for structural system. For the ground floor, for the construction area of 60.12 meters square, the IBS score is 0.7 and the coverage is 0.32, and the IBS score for that ground floor is 11.2. And for the first floor, for the construction area of 64.80 meters square, the IBS factor is 0.7 and the coverage area is 0.34, and the IBS score for this first floor is 11.9, and for the roof is a construction area of 64.80 meters square and the IBS factor is 1 and the coverage area is 0.34, and the IBS score for this roof is 17, and the total IBS score for structural system is 40.1. Calculation for wall system. For the ground and first floor we have used external wall of block work system, and for the internal wall we have used prefabricated wall panel. For the ground floor external wall we got 3.8 IBS score, and for the internal wall of ground floor we got 2, and for the first floor the external wall is 3.3 and for the internal wall is 3.8. So the total for this wall system is 12.9 IBS score. Calculation for the other simplified construction solution. For the beam of dimension of 300 times 500 and the unit is 50 nos and the usage is 100%, so the point that we get is 4. For the column the usage is 102, the point we get is 4, and for the wall the usage is 71.5%, so the point is 2, and for the slab it's 100%, the point is 4, and for the door is 100% too, the point is 4, and for the window 100% usage, the point is 4, and the total point that we have calculated is 22. So the point awarded for this category is 16 because the maximum point that awarded to this category is 16. For another subcategory of productive enhancing solution and technology adoption, we have used two methods, which is building information modeling, apply BMI level 2 between project teams, which is 6 points, and the usage of modular grid lines in drawing, which we have obtained 6 points too, and the total points calculated for this is 12 points, and the maximum point for this subcategory is 12.2. The total IBS score calculation for the double story terrace development is, for the part 1 sectional system, for the maximum IBS score is 50 and we have awarded it 40.1 IBS score, and for the part 2 wall system the maximum is 20 and the awarded IBS score is 12.9, and for the part 3 other simplified construction solution the maximum is 30 and the awarded IBS score is 28. So the total IBS score is 81 per 100.
Good morning and afternoon everyone. Next, I will present the technical details of our project through the engineering drawings prepared using AutoCAD. Okay, first thing, for modular coordinate MS1064. First and foremost, looking at the layout plan, the entire design of this building is based on a modular grid that compiled with MS1064 Part 1. The use of modular grid lines on both the X and Y axis is crucial to ensure that the prefabricated IBS component can be installed accurately without requiring major modification on site. This adherence allows us to achieve full points for the standardized components category. Okay, for second part is ground floor structure plan. Moving on the beam ground floor plan. Here we adopt a hybrid system. For columns, we use in situ column size 300 times 600 mm C1 and 400 times 600 mm for C2. Although cast on site, we utilize a reusable formwork system. This strategy is cost effective while still contributing on IBS factor of 0.7 to our structure score. And for walls, for the external walls on the ground floor, we utilized a blockwork system for the durability. Okay. And then for first floor structure plan and IBS component. On the first floor, the application of IBS is more intensive. For beams, as shown in the beam schedule, we utilize fabricated beams code BV1 with a size 300 and 500 mm. Using factory produced beams significantly speed up the assembly process. For slab, the first floor flooring utilize fabricated slab code S1 with a thickness of 150 mm. This minimizes wear threads and formwork requirement on site. And then lastly, for the roof system and standardization. Finally, for the roof structure, we implement 100% prefabricated roof trusses. Additionally, our door and window schedule demonstrate that we have standardized the component size such as window 1, window 2, and doors D2 and D3 to maximize the uses of standard component. All these elements into the drawing translate directly into our height IBS score calculation. And next for 3D modeling, Revit and BIM. Okay. Next, I will walk you through the evaluation of this project using the 3D model developed in Revit. Okay, first, BIM level 2 implementation. This 3D model is not just a visualization, it represents the implementation of BIM, Building Information Modeling level 2 in our project. By digitally modeling every component, we can ensure better coordination between architecture and structure element before actual construction begin. Through this 3D view, you can clearly see how the IBS component I mentioned earlier are connected. You can observe how the prefabricated beams BV1 are seated onto the in situ columns. The arrangement of the prefabricated slab on the first floor is also visible, illustrating the reduced need for extensive propping underneath. The structure is designed to support load and efficiently while essentially adhering to JKR specification. IBS core verification. This 3D model also serve as a verification tool for our IBS core. Every model element possesses parameters that contribute to our total score of 81 point. The structure system contribute 40.1 points. The wall system contribute 12.9 points. And other simplified solution, including the beam usage and modular grid length, contribute to 28 points. So, in conclusion, the AutoCAD drawings and the Revit model demonstrate that this double-story terrace project not only achieve the high IBS score, but it also constructible and compliant with current industry standard. So, thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Yusuf Hassan Yusuf, and in this video I'm going to present the final part of our project, which is the conclusion. The first point of our conclusion is that the structure system contributed the highest score due to first, prefabricated beams, slabs, and roof trusses. Second is that in situ columns are usable framework. Third is that improvement efficiency, quality control, and reduced labor. Our second point for our conclusion is that the wall system achieved a moderated score. The first is that fabricated panels for internal walls. Second is that conventional framework with external walls. The last one is that partial IPS adoption still shows positive progress. Our third point for our conclusion is that a highest score was achieved for other simplified construction solutions, which is standardized component and compliant with EMS 1064 part 10. Second is that adoption of BIM level 2 and modular grandness. Overall, the project complies with CIDB requirements, supports international IPS initiatives, improves the construction efficiency, quality, and sustainability. Further improvement can be provided by increasing the use of fabricated wall system in the future project. That is all for our project, for our group, for IPS class. Thank you so much for watching. That's group 8. Thank you so much.